Welcome class to our fourth video. The method that we are going to learn in this video is the Newton-Raphson method. Although Newton-Raphson method is a very quick method, it converges very quickly. That is from the approximate initial value that we take. It goes to the root of the equation very quickly in few iterations, not too many, but it also has a small drawback that the initial approximation that you take, that has to be a bit closer to the root. Okay, for example, if equation say might have a root of say 0.75, then our initial approximation should be in the range say maybe 2 or 3, something like that. So although it's an open method, it's still advisable to maybe calculate what the initial bracket of that equation will be and take an initial approximation, one of those two. Okay, let me give you the formula for this. Xn plus 1, that is the next approximate root, that is equal to the previous approximate root minus f of xn, that is the value of fx when x is equal to xn, the previous approximation, and f dash xn. Now what's this f dash xn? F dash xn is nothing but the first derivative with respect to x of the initial function, that is fx. Okay, so for example, if fx is equal to x raised to 4 minus 4x square minus 10, then f dash x, that's going to be 4x cube minus 2 4s are 8x, oh I'm sorry, 8x, that's it, right? 10 is a constant, so the derivative of that is 0. Alright, so the derivative of x raised to 4, that is 4x cube minus 4x square, that is 2 4s are 8x, that's the first derivative with respect to x of this function. So this is f dash x, this is fx. Okay, I hope that's clear. So now without further ado, let's start with our first example. Okay, solve x raised to 4 minus x minus 10 is equal to 0. Correct up to 3 decimal places. Using Newton-Raphson. Okay, alright, now let's write this down first. Fx is equal to x raised to 4 minus x minus 10. Okay, so f dash x, this is going to be 4x cube minus 1, right? Everybody got that, how I came to that conclusion? X raised to 4, the derivative is 4x cube minus x 1 minus 10, the derivative is 0. Okay, so that's fx and f dash x. Okay, now let's just calculate what the initial bracket would be. When f is equal to 1, then the initial value of fx would be 1 raised to 4, that is 1 minus 1, so that's 0, minus 10, so that's minus 10. What will happen when f is equal to 2? 2 raised to 4, that's 16, minus 2, 14, minus 10, 4, plus 4. So minus 10 plus 4, there has to be a root between 1 and 2, right? So let us take one of those values as our first approximation, x0. Suppose x0 is equal to 2, then f of x0 is equal to 4 just as we calculated right now. 2 raised to 4, that is 16, minus x, that is minus 2. 16 minus 2 is 14, minus 10, so 4, and f dash of x0, that will be 4 into x cube minus 1. So x cube, that is 2 cube, is 8, so 4 into x cube, 4 into 8 is 32, minus 1, f dash x0 is 31. Alright, so let's go with our first iteration. X1 will be x0 minus f of x0 divided by f dash x0, so nothing but 2 minus 4 upon 31. Okay, let's see how much that is. To 1.8710. Okay, what is f of x1? This one's a minus 10. Okay, 0.3827. F dash of x1, this is equal to 4 into 1.871 cube minus 1, 25.1988. Okay, right, so next iteration x2, that's gonna be x1 minus fx1 divided by f dash of x1, which is equal to 1.8710 minus 0.3827 divided by 25.1988. That is equal to 1.8558. Okay, what is fx2? Answer raised to 4 minus answer minus 10. F dash x2 is 24.56 55. Okay, does everyone have that? Okay, as you can see here, let me show you one thing, just let me point that out. Okay, take a look at what the initial x0 was, f of x0 was 4, right? From 4 it converged to 0.3827 in the first iteration. In the next iteration it came down to 0.0056. okay, so just take a look at how soon it has converged or gotten to the close to the root. Okay, so that's the that would be, I think, one of the properties of the Newton-Raphson method. That's a very quick method, it converges very quickly. Okay, alright, now let's take the next approximation, x3. That's gonna be x2 minus fx2 upon f dash x2, which is equal to 1.8558 minus 0.0056 divided by 24.1988. 5655, which is equal to, let me get that, 1.8558 minus 0.0056 divided by 24.5655. Okay, 1.8556. Okay, right, so take a look at this value. X2 is equal to 1.8558, 1.856. X3 is equal to 1.8556, approximately equal to 1.856, right? So the two roots are equal, which means that is 0.856. Okay, so that's your answer. Easy, right? Easy and quick. Okay, now let's move on to the next problem. Let's one second, let me find out. Okay, let's go for a little bit complex problem here. Solve x log to the base 10x is equal to 1.2. I think it's one of the previous examples that we took for bisection. Here's the real catch: correct up to 5 decimal places. Okay, all right, so x log to the base 10x is equal to 1.2, which means that x log to the base 10x minus 1.2 is equal to 0. Okay, so our fx is nothing but x log to the base 10x minus 1.2, then the f dash x is this one is a multiplication of two functions, so that would be log to the base 10x plus x into 1 by x log to the base 10 of e, which is nothing but log to the base 10x plus x and x are cancelled, and log to the base 10 of e is zero point 4343. Okay, let me just do one thing. 43429. We want up to 5 digits, which is why I took that one. Okay, log to the base 10x plus 0.43429. Does everyone understand? I hope you do, how I came to this conclusion, because it's fx1 into fx2. Then what we do is fx1 d by dx of fx2 plus fx2 d by dx of fx1, right? So here x and log to the base 10x. These are the two functions. In the first one, I kept the log to the base 10x constant here itself and took the derivative of x, which is 1, okay, plus in the next one I kept x as it is and took the derivative of this log to the base 10x, which is 1 by x log to the base 10 of e, okay, the natural log. So the log to the base 10x remains as it is, x and x are cancelled, and log to the base 10 of e, that is 2.718288182, that is 0.43429. okay, so this is our f dash x. Okay, now let's take our initial approximation here. F of 1, that is going to be 1 into log to the base 10 of 1, which is 0, so 0 minus 1.2, so this one will be minus 1.2. okay, take a look at this one. X log x, x is 1, log to the base 10 of 1, log to the base 10 of any value is always 0, so this one is 0, so 1 into 0, that's 0, minus 1.2, so f of 1 is minus 1.2. let's see what f of 2 will be. 2 into log to the base 10 of 2 minus 1.2. okay, this is minus 0.59794. f of 3 is 3 into log to the base 10 of 3 minus 1.2, 0.23136. okay, so there is definitely a root between 2 and 3. okay, so let's take one of them as our initial approximation. I will take that to be 2. okay, last time we took the higher value of the bracket, this time let's go for the lower one. x0 is equal to 2. okay, so fx0, as we calculated right here, that is minus 0.59794. okay, f dash x0, that is equal to log to the base 10 of 2 plus 0.43429. oh, I'm sorry, log to the base 10 of 2 plus 0.43429. okay, that is 0.73532. okay, so that will give us our initial approximation x1, that is equal to x0 minus f of x0 upon f dash x0. okay, to the next page, which my x1 will be equal to 2 minus fx0, which is minus 0.59794, divided by f dash of x0, which is 0.73532. 0.73532. okay, which is equal to 2 minus plus 0.59794 divided by 0.73532. okay, which is equal to 2.81317. okay, so that's our x1. let's see what our fx1 is. okay, that's all right. Now answer multiplied by log to the base 10 of answer minus 1.2. okay, so if x2 is 0.0, 6366. Okay, let's see what f dash x is. x1, that is log of 2.81317 plus 0.43429, 0.88349. okay, right, which gives us our x2, which is equal to x1 minus fx1 divided by f dash of x1, which is equal to 2.81317 minus 0.06366 by 0.88349. okay, 2.81317 minus 0.6366 divided by 0.88349. okay, which is equal to 2.74111. okay, fx2 is answer into log to the base 10 of answer minus 1.2, which is 0.00041. okay, f dash of x2 is log to the base 10 of 2.74111 plus 0.43429, which is 0.87222. okay, which gives us our x3, which is equal to x2 minus fx2 upon f dash of x2. okay, which is equal to 2.74111 minus 0.00041 divided by 0.87222, which is equal to 2.74111 minus 0.0041 divided by 0.87222. okay, 2.74064. okay, take a look here. If it was up to 3 decimal places, then we would stop here itself and say that 2.741 here and 2.741 here, which meant that the two were equal. But because it says up to 5 decimals, so always remember that how many decimals are given. It says 5, so we have to continue. The first 5 decimals have to be accurate. okay, so let's go for what is fx3 equal to answer into log to the base 10 of answer minus 1.2, which is minus 0.00001. okay, and f dash x3, that is equal to log to the base 10 of 2.74064 plus 0.43429, 0.87214. okay, which gives us our x4, which is equal to x3 minus fx3 upon f dash x3, which is equal to 2.74064 minus 0.00001 divided by 0.87214. okay, which is equal to 2.74064 minus and minus, it would be plus 0.00001 divided by 0.87214. 2.74065. okay, see how close we are. Okay, the last one was 74064, this one is 74065, but still the last digit is different, which is why we have to go one step further, just one step. I'm sure that would get it in this step. Let's find out what fx4 is. So answer into log to the base 10 of answer minus 1.2. okay, let's see if we get yes, 0.000005. okay, and f dash x4, that will be equal to log to the base 10 of 2.74065 plus 0.43429. 87214 again. 214. okay, so okay, let's go to the next page. Final step, I hope. x5 is equal to x4 minus fx4 divided by f dash x4, which is equal to 2.74065 minus 0.000005 divided by 0.87214. okay, let's find out what that is. 2.74065 minus 0.000005 and 0.87214. okay, it's 2.74065. okay, so x5 is equal to x4, which is why we can say that up to 5 decimal places. Root of the equation is 2.74065. okay, yes, I think that's that. Please, after watching this video, please do not forget to brush up on your derivation and integration skills. Of course that integration and derivation is needed here, but we don't need too complex functions like the ones that you had to solve in the 12th. Mostly the functions revolve around multiplication, addition, subtractions of the standard functions, that is quadratic functions, powers of x, sin x, log x, tan x. These are the functions that it would revolve around. So, and addition, multiplication of these, so you don't need to worry too much, but still derivation is needed, so don't forget to brush up on that, and best of luck. Thank you.